Hello and welcome to this presentation on desktop repurposing. This is a follow-on from a session that we first published in January 2019. I'm Matt Evans. I'm an EUC Solutions Engineer at VMware. I've been with VMware for 3.5 years, and prior to that, I spent 10 years with Wise Technology and 2.5 years at Igel. So in total, I've spent around 23, 24 years in the server-based computing and thin client environment.
And I'm Darren Hirons. I am a Senior Solutions Engineer working alongside Matt. My background is 25 plus years working in a variety of IT roles, from server infrastructure to IT management, and then eventually working within VMware.
In terms of the agenda for the session, we'll give you a bit of an overview of the project. So hopefully you've seen the previous session. If not, we'll have a quick recap. We'll look at some of the rules, so some of the ways that we test and what we're looking at. We'll look at the different vendors and the sort of environment we've done the testing in, and then we'll give you an overview of how the vendors came out and what the performance was of the image. And then finally, we'll look at a sort of, I guess, a case study, just sort of a hypothetical scenario of what it would look like to cost in terms of power consumption and things like that for 5,000 devices. So the project itself started back probably about 18, 24 months ago, where Darren and I looked at the various different vendors in the marketplace and really tested their different solutions. So how the imaging process works. So we're talking about imaging, we're talking about converting an existing PC or a laptop to run an operating system from one of these vendors. So it could be a Linux-based OS, it could be Windows, or it could be Chrome-based. And then we looked at things like how long those devices take to boot, what sort of power consumption they pull, and also what the user experience is like. So when you're connected to a Workspace ONE environment, when you're connected to a virtual desktop or application using Horizon. When we finished the project, we created a condensed session that we then took to various VMUG events, created blog posts, recorded a video, and published that on blogs and LinkedIn, and shared that with the community. In this session, this is kind of supposed to be a follow-up to the previous one. So we're not going to show as many videos and demos as we did last time. However, those are still valid. You know, the performance that we see today from, as an example, a Blast connection back to Horizon is still really good as it was back in January 19. So you'll see the link there. So if you want to revisit and see some of those videos and see some of the original content, you can do that using that URL below.
Yeah, we're just going to cover some golden rules for this presentation. So the test environment that we used was always the VMware test drive environment. The devices that we were running were always on the latest version of production code from each vendor. And we used the out-of-the-box configuration for each vendor too. So we didn't do any post-deployment configuration in any of the tests. We used identical hardware for every single vendor's testing. And we made sure that the endpoints were always plugged into mains power, because we didn't want any kind of power saving to kick in during any of the tests. As for the devices we used, they were the same ones we used in the test in 2019, based on the Latitude E7470, and the specification is below on the screen.
In terms of the vendors we looked at, they're all displayed on screen. There are a few other vendors in the marketplace, but for whatever reason, you know, they weren't tested. Some were quite niche and had a very small footprint, so we didn't look at them. There were a couple of vendors we reached out to try and obtain you know, code and firmware from them to do the conversion, and they didn't come back to us. So these are the ones that we focused on. What I will mention is that this time round, we didn't test the thin scale software, and that's for no reason. There's nothing wrong with it. It was a good solution, but it's really a shell replacement to Windows. Once you've done the shell replacement, you then go through and install the Horizon client. So because of that, we didn't feel like there was really much to gain by retesting it. So as I say, it's a nice solution, but it just didn't feel like we needed to go through and do a retest on that. So we really did focus on the vendors that gave the full operating system and not just that kind of kiosk replacement. In January 19, if you went back to see those recordings, what you would see is a number of different you know, demos and recordings that we took. So for example, you'd see a couple of the standard sort of NVIDIA recordings, so the aquarium and the kind of like the fairy garden. We also looked at performance in YouTube, as well as Windows Media Player or VLC Player, to look at kind of like AVI, WMV playback and the effect that had. As I say, I did do these tests this time round. I just didn't capture any video. So in the score sheets and in the final results, when you look at power consumption, it will say power consumption when running WS1 Horizon. What that really means is that we launched a Workspace ONE session and accessed Office 365. We also launched a virtual desktop, Windows 10 desktop, and in there, one of these things was running. And typically I was using the NVIDIA Aquarium to keep it apples for apples across, so all the same tests were done. As I said, if you go back to that January session, you'll be able to see the recordings and how they perform using both BLAST and PC over IP.
Just some quick details around the test drive platform itself. All these tests were conducted during April of 2020. The Horizon version at the time on the platform was 7.12, and the underlying OS for the desktops was running Windows 10 17.09. The specification of the servers on the test drive platform is listed below. As for the tools we used to do some of the measurements, we used a consumer sort of standard power meter. We used the stopwatch from in our phone, and we used a variety of USB devices which were used to install the actual media onto the laptops.
I know I mentioned that there wouldn't be any videos in this, but we thought we'd just show one. This simply shows that typical Horizon test. So here you see machines side by side. On the left is the BLAST protocol, and on the right is PC over IP. These are both going through a Horizon client back to a virtual Windows 10 desktop. And this was quite typical, that BLAST seemed to be a little bit smoother. So you can see PC over IP still handles it quite well, but it occasionally needs to sort of catch up a little bit, or it sort of slows down or jerks a little bit. So we found that. As we said, our rule is it's out the box. So it could be that you could make some tweaks, you could change it based on network conditions or bandwidth or latency. But as I say, our goal was just to use out the box configurations. So we've got to bear in mind is where we're using test drives, this is a European data center. So when we're testing in the UK, and it's going to a data center that's located in Amsterdam. Okay, so if we now start looking at some of the vendors, just a real quick chart shows you the different conversion options. So as you can see, pretty much all of them have the opportunity to reboot and re-image from USB. That's pretty common. A lot of the vendors offer their own tools. Equally, there are third-party tools that you can use. From the vendors, you're going to get, an ISO or a DD image or something like that, so you can create a bootable USB. For things like Dell and ThinScale, because these are Windows-based, then it's an MSI. So that ThinScale, that shell replacement would be an MSI, and equally, whilst Dell does some replacement and does maybe some more changes than just that kind of shell, because it has a write filter and things like that, fundamentally it's still an MSI that does that. There are some options for Pixie booting from some of the vendors, and some of the vendors have a option to do something via a PCLM tool. So if you had a PCLM tool that could maybe deliver a sequence that triggered a Pixie boot, then you could use the PCLM tool to actually kick off the process. So in terms of the vendors, we're going to go through them in alphabetical order. So there's no real way. That's the way we did it back in January. So we'll just follow that same suit. For every page, for every vendor, the layout's the same. On the left, you see kind of the title, so the date of the testing, the hardware, the firmware version, those sort of things. The middle column is the results from when we last tested the code. And then on the right-hand side is the most recent testing. So on the right-hand side, it should all be April 2020, and in the middle. So rather than going through and reading out everything line for line, we're just going to call out some of those changes, and that will be the format throughout. So if I look at Tenzig, you can see that the imaging time, so booting from the USB and converting it to the Tenzig image, took a little bit longer, relatively negligible, 7 seconds, but therefore boot time was actually a little bit quicker. So, boot time was improved, which is a good thing. Other things that are going to be common throughout are the Horizon client is going to be newer. Obviously, the firmware version is going to be newer. So again, I'm not going to dwell on those too much. In terms of power consumption, when the device was just sat there doing nothing, there was a slight increase in power consumption. Equally, there was an increase in power consumption when we were running that Workspace ONE and Horizon session. I have spoken to Tenzig, and this isn't traditionally something they'd focused on, but this is something that they're looking at going forward, is to drive down power consumption. So I would expect that to change over the course of future firmware releases.
Next up, Atrust. So we tested the Atrust again, the same as Matt just discussed. We found that the image time was significantly improved, over 30-second improvement, and there was a slight improvement in the boot time as well. The Horizon client, as always, has been updated to the 5.4 version. And when it comes to power consumption, we saw a slight drop in idle power consumption, but a slight increase in the workload power consumption when it was running the Workspace ONE and Horizon workloads.
For Dell, there was a slight change in the code base as well. So when we originally tested back in April 2018, the Horizon client was included in there. It was a slightly older version, but it was included. And the way it worked is that when you installed the software, if it detected a Horizon client existed, it didn't install the one that was bundled in. So I thought that was quite a nice solution, but it was decided, and I think feedback from the field was that people that were doing the conversion already had the Horizon client. This wasn't really that necessary. So now the code doesn't actually include a Horizon client at all. So if you did have existing PCs with a Horizon client installed, you'd install this over the top and carry on as you were. If these were fresh devices, you would need to make sure you deployed the Horizon client as well. In terms of the actual conversion process, significant improvements, again, similar to Atrust. So we've seen a conversion time reduction in 6 minutes, and boot time is slightly quicker, but obviously we're down to seconds here. In terms of power consumption, similar in terms of idling. So with the device just being sat there doing nothing, the same, and a slight increase with regards to running that Workspace ONE and Horizon session. But again, it's not hugely, I wouldn't expect that kind of change to induce much cost in terms of power consumption.
Next up, Igel. So again, we noticed some slight differences in things that we measured. So imaging time for one was significantly slower, up 1 minute 21 seconds. And there was a slight increase in the boot time as well. The power consumption when idle actually went down, and the power consumption when the workload was running actually stayed the same as the test we did 2 years ago.
One thing I would add to that is that I did check around imaging process with Igel, and they came back to me over the last couple of days, and they mentioned that they would expect a slightly longer imaging time from previous firmware because they're now doing user space encryption, and the image itself is bigger because there's more functionality in it. So when I mentioned that the actual imaging time was a bit longer, they weren't too surprised by that because of the encryption that they're doing. So in terms of Neverware, this is, I guess, kind of a unique one because this is the only offering that we have that is based on Chrome. The others are based on Linux or Windows. So here, again, imaging time was up by, sort of 4 minutes and 14 seconds. There was an increase there. The boot time itself was up as well. And maybe this is sort of a little bit common across the board because over the last 18 months, 24 years, firmware and image sizes have got that bit bigger and they have more functionality and they're doing more. So that could just be down to natural growth. In terms of power consumption, we did see reductions in both idling and when accessing Workspace ONE and Horizon, which was a good thing.
Next up, we have Praim. So there was a slight increase in the required imaging time, up 19 seconds, but boot time had a fairly significant improvement of 34 seconds. Power consumption when idle was up slightly, and power consumption when Workspace ONE and Horizon workload was running came in at 29 watts. Now, the reason why this wasn't recorded previously was due to a bug in the Praim client we tested in 2018, which meant that particular test couldn't be measured.
For Stratodesk, you can see, again, a slight increase in that imaging time, and boot time was down. With regards to power consumption, when idling, it was down a little bit, and when running that Workspace ONE and Horizon, it was pretty negligible, so a slight increase, but nothing major.
Next up, we've got ThinScale, and as Matt mentioned at the start of this presentation, we didn't retest this year, but we just thought we'd leave the previous test in just for reference.
So for Unicon, similar imaging times, similar boot times. In terms of power consumption, so quite significant reductions there. so down to 12 watts when the device just sat there idle, and a reduction in 11 watts when running Workspace ONE and Horizon session.
Onto VXL, we saw slightly slower imaging time, 49 seconds slower. We saw a slight increase, just 1 second increase in the boot time. Fairly significant powering decrease when idle, down 15.5 watts, and a slight increase of just 2 watts when the workload was running.
Another point of reference is that Stratodesk, have a version of code that will run on a Raspberry Pi, and we tested this back in December 2018, so just before that January 2019 release of the first version. But due to the low imaging times, low boot times, and low power consumption, and also because it's based on that Stratodesk image, which we did retest, we didn't feel the need to retest on Raspberry Pi. But again, we thought we'd leave this in here as a point of reference. So in terms of summary, first time round, we used a hypothetical scenario where we had 5,000 desktops that were being converted from Windows 7 or Windows 10 to run one of these operating systems. When we pulled out the results, we looked at the average costs of a Windows conversion, Linux conversion, and Chrome. Obviously, Chrome is pretty straightforward because there was only one Chrome vendor, being Neverware. But for Windows, what we did is we would take the cost of the Dell solution, the cost of the thin scale solution, and divide it by 2 to get our cost. Likewise, we did the same for all the values. So for imaging time, for boot time, for power consumption, and that's how we split it. We then looked at the cost of energy, and then we worked out the cost of devices being idle. So lots of the vendors would support sort of wake on LAN and remote shutdown and things like that. So you can make further power savings by sort of powering down the devices remotely. But for the purposes of this, we just thought, well, if they're left on 24/7, what does that cost look like? What does the cost look like per device per month when they're actually working, accessing Horizon, accessing Workspace ONE? And then what's the cost for 5,000 licenses to do that conversion? And then what's the cost in terms of electricity to run 5,000 devices per month? Okay, so these are the results from January 2019. So we did that again for April 2020, and these are the results we see. This time around, Windows has come down a lot, and that's really because we only tested Dell, so that cost of thin scale wasn't in there, therefore the results are a little bit different. I'll actually put them side by side. So if we go to this next table, similar to the way we did it in the previous slides, you've got brackets that show the difference. So in terms of things like imaging time and conversion and boot times and things like that, there's slight ups and downs and some little changes. Power consumption it is changed in some. So if you look at power consumption for Linux, it's come down quite a bit. It's also come down quite a bit for Chrome. It's a slight increase when you're working for both Windows and Linux, but not vastly. So all those things affect those costs that we've got there, those per device per month when it's idle and when you're working. And obviously the cost of the licenses has changed just based on that top line average cost number. But if you look at that power consumption for the 5,000 for the month, you can see that Windows is an increase of sort of 500 odd pounds. Linux is an increase of 600 odd. And then Chrome is a decrease of 500. And that decrease of Chrome has really come down on the reduction in power consumption that Neverware have made. It's not based on licensing. The thing that you find there is that, because of the way we're doing it, and if you look at Linux, there will be a few vendors in there that have skewed the results a little bit. There'll be some vendors that have made an improvement in terms of power consumption, therefore their results independently would be really good, but when it's lumped in together here, it can skew it a bit. But this is just to give you a kind of a view as to what it would look like for an environment that might be running 5,000 users. So from Darren and I both want to thank you for your time and hope you found this of interest and this information useful. We will be publishing this on our blog sites, on LinkedIn and Twitter, kind of the usual platforms. So if you have any questions or want any sort of points of clarification around any of the data or any of the tests that we run, please feel free to reach out to us. Thanks for your time.